So today we'll start our discussion with router component, and then we will see the categorization or classification part, and then we'll go with the dynamic routing. And basic dynamic routing is our RIP routing protocol that we will see. Okay, so let me take one router here. So I'm taking this 1841 router. Okay. So I'm using this operating system here 12.3, and it is just booting up. Okay, and first time we see this message. Why we are seeing this first message? Because we have a different kinds of memory here. Okay, so we have a ROM, then we have a RAM, then we have NVRAM, then we have flash. These different memories we have. So in ROM we have two things, important things. Okay, it is used for maintenance purpose also. So we have option of in ROM we have a process means like actually we have a software, it's called as BIOS software. Okay, and it executes the process called as POST, power on self test. It is used to check whether router is having or the device is having all the important components intact, like controllers, the different input like a different control systems in it, then memory, then CPU. If everything is okay, if anything goes wrong with the internal components, this post will not give a control to the next phase, and the next phase in this is bootloader. Okay, bootloader. And once we have bootloader loaded, bootloader will find out the operating system from the flash. So operating system, we have a internetwork operating system that's placed in flash in the compressed format. It's a binary file. Okay, you can see here this this particular file. It's mentioned somewhere. So I'll show you the exact binary file where it is placed with the show flash command. So it is there in the flash, and that will be loaded into RAM. And after that, according to the config register, okay, config register values, operating system, the data from the NVRAM will get loaded into RAM. So whatever settings we have saved in NVRAM will get loaded into RAM. If you want to bypass this behavior, we have to make the changes in configuration register. I'll talk about configuration register more in the device management session, where I'll show you how to break the password on the device like router and switches. Okay, and that time we will discuss about configuration register. Okay, that is also one kind of memory, but we will not discuss about that because that will create a confusion at this level. So we have a saved configuration in NVRAM. So that file name is startup configuration, and a RAM we have a file called as running configuration. Running configuration. Okay. So file whenever we make changes, that change are there in the RAM, and the file name is running configuration. And if you want that say changes to be saved on the device uh, for the next reboot, or you want that changes to be persistent for, okay, so that time you have to run a command copy running config to startup config, and that changes or those changes will be saved in startup config file, and that startup config file is a part of NVRAM, non-volatile RAM. So when next time device reboot, startup config will get loaded into RAM, and whatever configuration is there, suppose password we have set, so that password will be asked, okay, because in startup config we have a password setting, so that password will be asked to it's like a enter into the command prompt, then you will be able to access the device on the privilege levels, like privilege level 15 or higher privileges. Okay, so these different memory we have. Furthermore, we have CPU. So just like any computing device, we have a CPU also. So if you expand this, so we have a power supply system, we have CPU system. So all instructions are executed on the CPU. And in addition to this central CPU or backplane CPU, we have individual port CPUs also, that's called as ASIC, application specific integrated circuit, for individual ports as well. Okay, to speed up the process and to give the high throughput on the device. That's why the devices like Cisco and Juniper give higher throughput as compared to the devices like a normal switches or no name switches like D-Link or TP-Link. You will get more features on Cisco and Juniper because of this ASIC or a special circuitry per interfaces basis. Okay, so I hope this gives you a broad idea what this devices is like, a what are the different components okay, on the Cisco routers. Next, we have to discuss about the uh, categorization on these things, routed and routing protocol, and the different categories of routing. Okay, so first we'll discuss about routed protocol and routing protocol. So as you can see on the bullet points, we have a routed protocol called as IPv4, IPv6, and we have a routing protocol like RIP, EIGRP, OSPF. So guys, our data plane traffic is carried through this routed protocol, and our control plane traffic is carried through routing protocol. Do, we have discussed about the data plane and control plane previously. Srijesh, do you remember?
No, no,
Not yet, no. So
not that.
see, control plane, if I give the best example or simple example is like this. In city, any city, in the city where I'm living now, the Bangalore, traffic is a huge problem. But if I remove the traffic officers from the four ways or on the road, this problem will again more increase. This problem will go at the peak. Then no one can move the vehicles over the roads. It's very difficult. So all police officers are just like a control traffic or a control plane. Okay, and the vehicles which move on these roads are like a data plane traffic or a routed protocols. Okay, so what I mean to say, see, this these roads are not built for these police officers, right? These roads are built for the normal public like us, who are like a commuting daily from on a daily basis, like from one locations to another location, from office to home or home to office. These roads are meant for them. But but without control plane traffic, or without control plane, without controlling this traffic, no one can reach to the place. It's very difficult, or this process will further get delayed. Same is the case with the computer network as well. So user wants to communicate on server. So our user wants to send data from one computer to another computer. So that will be counted as what? Data plane traffic. Okay, and that will be carried with IPv4 or IPv6. But to facilitate this traffic, we have a routing protocol on the router, which will make, means like a router 1, router 2, router 3, multiple routers we have, suppose. So they will communicate with each other and share their routing table among each other, and they will facilitate this IPv4 traffic or IPv6 traffic from one locations to another locations. So this routing protocols can be considered as what? Control plane traffic. And the user traffic is carried on this IPv4 or IPv6 packets. Okay, so that will be considered as what? Routed protocol. Okay, guys, you understood this point, what is a control plane traffic and what is data plane traffic?
Yes.
Okay, there is one more plane that is not relevant here, but just to explain in a flow, there is one more plane called as management plane. So from the name itself, what do you understand, what could be a management plane traffic? Just like a data plane is a simple user data is traveling over data plane, and the control plane is the control of the routers over this IPv4 IPv6 packet. So likewise, management plane means what?
I believe it will be taken care by the admin or
Hmm, correct. So the telnet SSH session, or if you are accessing the HTTPS or HTTP graphical user interface of firewall or router, that we can consider as a management plane traffic, because you are giving instructions to the router that this thing has to be done like this. So suppose you want a default route in our router, so you are giving a command like IP space route space 0.0.0.0 with the subnet mask of 0.0.0.0 and the next stop IP address. So you install that route, default route, into the routing table. So you instructed that router. So this particular command and this particular instruction data, which is going from your computer as a NOC engineer or a network engineer into into the router, that particular traffic, SSH traffic or telnet traffic, can be considered as a management plane traffic. Okay. I hope this make make this explanation or this analogy made you clear the point of data plane and the control plane, and what is the role of routed protocol and what is the role of routing protocol. Next we have this categorization, or we can say classification. Okay, uh, so routing is divided into this static routing and a dynamic routing. Basically these two broad categories we have: routing into static routing into dynamic routing. Furthermore, we have seen yesterday the static routing is divided into two kind of routing. One is a specific route, okay, and one is a default route, or a gateway of last resort we set through this default route. So these two settings are there in the static routing point. But we have seen the drawbacks also. Static routing we can use for smaller environment where uh, the number of routes or a number of routers are less, and it's not subjected to changes. If it is like a fixed setup, that time we can utilize static routing. But it is not good for the environment where the changes are happening. Furthermore, we need a failover automatically. So that time dynamic routing will be a better category for us, or better routing method for us. Okay, so we'll go with the dynamic routing, and most of the time you have to deal with the dynamic routing, and it is divided into two sections. One is EGP and the other one is IGP. EGP stands for exterior gateway protocol, whereas IGP stands for Interior Gateway Protocol. Exterior Gateway Protocol means not within a company, but one company to another company. So suppose I have a company with a name Networkers Home, and I want to connect it with the internet. So I will connect it with this exterior gateway protocol, and the name of that protocol in this category is BGP, Border Gateway Protocol. Whereas this IGP is used within a company only. So suppose I have a multiple branches, Networkers Home at Bangalore, we have one office. Suppose we have one office in Delhi, and one office we have in Pune, one office we have in Chennai. Okay, like this we have the presence in multiple cities. So, and I want to do a routing on these multiple branches. Okay, so that time I'll use IGP, Interior Gateway Protocol, because all these branches belongs to our company, and this is one autonomous system number, means the I have a full control. I have a full control within my organization. Whatever VLAN setup I want to do, I'll do that. Whatever networks I want to set, I'll do that. It's it's in my control. So I'll consider it as a one autonomous system, and that will be considered under one IGP or Interior Gateway Protocol. This Gateway Protocol is further divided or subcategorized into three sections. The one is distance vector. I just written in a short uh, DV, and second category is link state. Okay, I written it as LS here, and third category we sometimes call it as hybrid, but the more appropriate name is the advanced distance vector. Okay, advanced distance vector. So let me give you an example for each of them. For distance vector, we have example like RIP, routing information protocol. Whereas for link state, we have example as a OSPF, open shortest first protocol. And for advanced distance vector, we have a example like EIGRP. So one by one, we are going to study all of them. So I'm going to start with distance vector first, then I'll move to EIGRP, and then at last we will study the OSPF. Today probably we'll just discuss about distance vector and RIP, and if possible we will do some discussion on EIGRP. Okay, that will get completed in the next session, and after that we will do a study of OSPF. So this is my agenda for routing. Okay.
So, Samir, what is the basic difference between the static and dynamic routing? Static,
uh,
it's mean we are manually. Uh,
Entering the
give,
routes or
okay,
installing the routes,
okay,
and in dynamic, uh, the same example which we have taken. So if I mean, suppose I'm working as a master over these three people. Okay, and I'm instructing them where to go and which direction they have to go, which routes are connected, all instruction I'm giving to them. Okay, so that will be called as static. But in case of dynamic, I remove my role from this. Okay, I let them talk to each other and decide themselves where which street is connected. So they themselves are deciding which street is connected where, or which network is connected where. Okay, so if any network goes down, i don't have to I don't have to instruct any of the router. They themselves manage the alternate path, or they themselves manage the updates to others. Suppose this street 40 goes down, so this this person will update it to B and A. I don't have to instruct that to A and B.
right,
Okay, so that's a benefit actually, that the
absolutely.
updates will be done. But see, if we have a low end resource and the network is very small,
Mhm.
and we can manage with the static route also. If it is like a four router or three router setup, only 3 to 4 branches we have, and very few routes we have within a 10 networks only. So instead of running a dynamic routing protocol, we can go with the static as well. It's not a big deal. Okay, so I can put then low end router also, okay, which are having a less resources on CPU, less resources on memory, and they can work well. But if you want a dynamic routing protocol to be running there, like a OSPF or EIGRP, we need little advanced router which can support CPU consumption and the memory consumption for these routing protocols.
So in real scenario, basically we will use the dynamic routing.
Yeah, in enterprise
Right,
enterprise business, hardly you will see static routing to be implemented for internet works.
right.
Okay, but suppose if there is a newly commissioned branch, a newly started branch, and it's not yet included in the dynamic routing protocol, so we can temporarily connect it with the static routing. That's okay. It's like a
Right,
one one path only that's connecting, and we don't have to like worry about this in the dynamic route. Afterward we can include it in the dynamic routing. So for temporary purpose we can include it in a static routing.
right. Got it.
Okay, okay. Next, let's again come back to this chart which we were discussing. So we start our discussion with the distance vector routing protocol, and we'll discuss about the link state and hybrid. Before this, I'll show you this, and again I'll come back here and I'll do a comparison between distance vector, link state, and hybrid. Which one is a more appropriate for enterprise business, and which one is less desired in the enterprise business? Okay, that comparison we will do after doing some practicals on a RIP routing protocol, which is a part of distance vector. Okay, so, and along with that we will study some theoretical points on distance vector as well. So I'm going to take two more routers here, and I'm going to connect them together. I believe yesterday's lab is ready. We can use that as well. On top of, we can use the previous lab also for this. Okay, let it be. So guys, if you observe this network, this is the enter network with three sides. I considered it here as a Delhi, Mumbai, and Chennai. Three branches I consider. Mumbai is the central one, and Delhi at the end. One end we have Delhi, and the other end we have Chennai. So it's like a North India is covered in Delhi, and the South India is covered under Chennai, and in the middle we have a hub location or the central location as a Mumbai. Okay, so we have branches at three different locations. Okay, and I want them to be connected with each other. So let's change this network. I'm going to change this with 12.0 number 12.0.0.0. Okay, here, and I'm going to change it with 23.0.0.0. Okay, so guys, how many networks we have in this internetwork? You can see Delhi has one LAN, and Mumbai has one LAN, and Chennai has one LAN. So total three LAN networks are there. How many WAN networks we have? We have one WAN connected with Delhi, correct, and second WAN is connected with Mumbai. So total we have uh, five networks, three LAN networks and two WAN networks. Okay, so this is how our internetwork is designed. Okay, so let's see the configuration here on the devices what we have. So few things are already configured, like host name is already set. Let's check the on running config, show running config, what we have configured so far. Host name is set. IP address for the IP address for the LAN network is set 192.168.1.1. Okay, but for this interface we are not worried about right now. We will keep it as it is. The serial interface I kept the IP address 192.168.12.1, that I'm going to change now. And I have one more interface. This also I'm going to change now. Okay. And some EIGRP routing protocol, RIP routing protocol, everything is going. Let me do one thing. I'll remove all these settings. What I'll do, I'll erase the startup config if it is okay, and I'll reload the device. I want to do it from scratch. This configuration, I'll do it from scratch. Same I'll do on the Mumbai. So if it is already configured, remove that settings, erase startup config. So previous settings will be removed and I'll do a reload. The device is reloading now. Let's repeat that same process on Chennai. Erase startup config and I'm going to reload this as well. Okay, I hope Delhi is reloaded now. Yeah, it is reloaded and it is entering into system configuration dialog. But I don't want this to be entered into system configuration dialog because I don't want to do the configuration with a wizard kind of thing. Okay, so like a Windows, we have wizard next, 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 finish, but you will not understand what's done in the configuration. So from scratch, we will do the configuration by command basis. So I'm going no command here, or for that I gave the no command and I entered into my user mode. This is my user mode. Okay, then I gave the command enable, in short en, and I entered into privilege mode. Now I'm giving configuration configure terminal command and I'm entering into the configuration mode. Let me set the host name now. I'll give the host name Delhi here. Okay, and let me check the show IP interface brief output. That will show what IP interfaces we have here and what IPs are assigned on them. So we don't have any address assigned. It's a blank router now. So let's start configuring the LAN interfaces first. So this is F0/0. That's a LAN interface. Okay, IP address with the default subnet mask. No shutdown command. So it's now on. Let's go one step back. Again, I'm in the configuration mode. I'll go to serial interface now. I'll set the IP address according to our setup on the or as per the label on this. Okay, so I'm going to give 12.0.0.1 at the Delhi side and 12.0.0.2 at the Mumbai side. Okay, that's done. Let's do the same thing on Mumbai, and so I'm doing configuration for the Mumbai router now. First, I'm setting the host name MBM in short. I'll do the first configuration of F0/0 LAN interface. 2.1, the first IP address in my network of 2.0, 192.168.2.0. Then I'll give the IP address. I'm repeating the same thing now. Let's get one step back. Interface serial 000. Set the IP address 12.0.0.2. We need to set it with the default subnet mask of /8, or you can say 255.0.0.0. Now shut down.
Sumit, this is static routing, right?
No, this time we are going to do a dynamic routing. I'm just making the interfaces up right now. Okay, once we have a connected routes available, then we will start with the dynamic routing.
Okay,
Static
just
route,
we are assigning the IP address for interface.
first of all, we need to assign the IP address. If you have a connected routes, then you can go with the dynamic routing, right?
Okay.
So we done with this serial interface at which is connecting to the Delhi side. Now I'm doing the configuration on another WAN interface which is connecting to the Chennai side. Okay, Mumbai to Chennai. So what IP we have here? 23.0.0.2. I'm repeating this command and I'm making some changes here. 23.0.0.2. No shutdown. That's it. So we're done with Mumbai's setup. Now let's move to the Chennai part. Now I'm on Chennai router. Let's set the host name first. CHN in short for Chennai. Then interface. What interface we have here? This F0/0 is the LAN interface. Then I'm taking this WAN interface here, serial 0/0/1, because this interface we have here, and I'll give the IP address. This end we have 23.0.0.1. We have already taken 23.0.0.2 at the Mumbai end, and I'm taking 23.0.0.1 at the Chennai end. Okay, we can do some verification command here. Show IP interface brief. Okay, we can see here all things are set correctly. This is my LAN interface correctly configured. Then I have this WAN interface which is connecting toward the Mumbai, and then we have Mumbai setup and Delhi setup. Let's do a cross verification on Delhi side first. Show IP interface brief. Okay.
So Samir, we haven't set up the switch route yet, no?
Switch we are not going to play with now
Okay, okay,
because it's a VLAN 1 setup for switch.
okay,
Okay, so this is my network 192.168.1.0 LAN setup for Delhi. So I don't care
okay,
about the individual VLAN setup. If you want to set multiple VLAN, then
hmm,
we'll do a configuration at the switch end.
okay, fine.
Okay, now this Delhi configuration is also okay on the interfaces. Next, we will check the routing table for them one by one. So first, Delhi's routing table. only two connected routes are there, and that's what expected also, because only two links are there on the daily router. One is this LAN link, the other one is a WAN link. So accordingly it's getting reflected in my routing table as well. C stands for connected. Okay, connected with the serial interface, connected with the fast ethernet interface. Okay, so it's okay. Let's check on Mumbai. So show IP route. So here also two WAN links are visible, or WAN routes are visible, and one LAN link is also visible. Okay, and Chennai routing table also we can cross check. Show IP route, and here also as expected one WAN link and one LAN link of 3.3.192.168 at 3.0. So all good. We can move ahead with the dynamic routing protocol. So first we will implement distance vector routing. Okay, distance vector routing, and we have two routing protocols under this categories. One is RIP. Okay, and it has two versions, version 1 and version 2. And we have one more routing protocol that's again in RIP, that is IGRP. But this routing protocol is deprecated in Cisco iOS, so you will not see support for IGRP. If it is very old legacy router, that time only you will see IGRP. Otherwise, you will not see IGRP supported anywhere on the Cisco routing protocols, Cisco routers. Okay, so RIP version 1 and RIP version 2 are supported on Cisco as well as the other vendors also. Okay, but how we are going to implement it and what drawbacks we have on this distance vector routing protocol, that we will see while configuring these routing protocols. So we'll do the configuration. Along with that, we will discuss about the theory of this RIP. RIP stands for routing information protocol. Okay, so we need to go into configuration mode, and we have to run the command router. And if you put the question mark here, so see guys, we have all four types of routing protocol supported in our platform. This packet tracer is actually supporting these four protocols only, but if you take real devices that may support more than this, there is one more protocol called as ISIS, intermediate system hyphen intermediate system. So that protocol normally we don't use it, but we use it for the service provider network or very large network. That ISIS is also good, but that's not in the scope actually. Means even not on CCNP as well. It is there on CCI level. It's a bit complicated as compared to the other routing protocols. Okay, so the simplest one or the simple configuration we have on the RIP. So that's why I'm starting my discussion with the RIP routing protocol. Okay, next we have EIGRP. That's little more complicated as compared to RIP, but more features are also available in EIGRP, and whatever drawbacks we have on RIP that we will discuss soon, that all also removed from the routing protocols in EIGRP. Okay, and the best routing protocol in IGP level, we have OSPF according to me, uh, and we have reason also for that. We'll discuss that soon. And for exterior routing protocol, exterior gateway protocol, we'll discuss about BGP. So let's get started with RIP first. So I'll start with RIP, and simply we have to enter here, and you may have observed here now my prompt has been changed to config hyphen router. So we are in the router configuration mode. Okay, especially RIP routing we are doing now, and we have to give command like this: network 192.168.1.0. Okay, and then we'll give a command 12.0.0.0. Okay, we need to enter a network, not the individual IP addresses. And when we give this network command, so whatever interfaces are falling under this network statement would get enabled for RIP routing process. Okay, and updates of this routing table will start floating in from the interfaces, especially this F0/0 interface, to the other ends. Okay, I'll show you that in my simulation mode. So let's see this thing in simulation mode. If I click here and if I put the event list in RIP, okay, so I just enabled a RIP routing protocol here. Okay, and let's do a capture and forward. So you can see we are sending packets. Okay, so RIP is basically using this protocol UDP at layer 4. Source port and destination port is 520. Source IP address is the interface IP address, whereas the destination IP address is layer 3 broadcast IP address. Okay, and layer 2 we have HDLC information. That's a different protocol for the serial link. But if you check this packet which is on the Ethernet link, you will see the destination MAC address is 12 time F or all F. So this is layer 2 broadcast. So in layer 3 also we have broadcast, and in layer 2 also we have a broadcast. Okay, so this is a broadcast based routing protocol. Which protocol is broadcast based? RIP version 1, but we have a different behavior with RIP version 2 that we will soon see in a different scenario. In a, means like on same case we will make some changes and we will observe the RIP version 2 as well. So this packets are getting dropped at Mumbai router or individual PC0, PC1, because this process is not enabled yet on Mumbai router. It is not yet enabled on PC0 and PC1, by the way, is not going to respond to these updates messages coming from Delhi router. Okay, it's like a Delhi router is yelling out its information of routing table to the adjacent router or the routers in the neighborhood. Okay, but this Mumbai router is totally ignorant about it. So let's do the configuration on Mumbai router and we'll see how this information will get absorbed in Mumbai router. So I'm on the Mumbai router now. I'll repeat the similar kind of configuration on Mumbai router, and the command here is network. In short, I can write net 12.0.0.0, and I have one more network on a similar line 23.0.0.0, and one network as a LAN network 192.168.2.0. Okay, so configuration is not that difficult. You can understand, it's very simple. So previously I was having a route for three network, this connected routes 12.0, 23.0, and 192.168.2.0. Now let's see, is there any improvement, any other routes that that is coming from, means updates coming from Delhi router is getting absorbed and in the Mumbai routing table or not. Okay, so it's visible, you can see here we have a route coming from Delhi router 192.168.1.0. So Delhi router has advertised its network 192.168.1.0 to the adjacent router Mumbai. Okay, and this information is coming via 12.0.0.1. Okay, and what time it came? Like 13 seconds has been done. We have received this information. If I repeat this command, now it is 14 seconds. If I repeat this command, it is 15 seconds. If I repeat this command again, now it is 20-second old information. Now this information is 22 second. Now this information is 24 second, and after that it goes to 0. Okay, means this is a recent information we have received. Again do the 7 second has been done, 8 second, 9 second, 10 second, 11 second, 12 second, 13 second, 14 second done, 15 second done, 17, 19, 20, 22, 24, 25, 26, 0. Guys, are you able to like a are you able to interpret this, why this is happening? So what is the role of this timers? So this timer, let me show you on a show IP protocol command. So guys, you can see here sending updates every 30 seconds. So we are receiving update from daily routers for this network. Which network? This 1.0 network every 30 seconds. So when we receive it, that time it becomes 0 time. Okay, means like just now we received this update from 12.0.0.1, and this timer keeps on increasing until we reach to 29 second, and on the 20 after 29 on 30 second it will be get refreshed by the daily route. I hope this cleared the point of routing updates. So like a Delhi is sending updates to Mumbai every 30 seconds. Similarly, if you go to Delhi router and do the similar analysis, you will find it out that similar thing is happening on the Mumbai router as well, Delhi router as well. You can see here, this is 3 second. Now this is 6 second. This is 8 second, 10 second, 11 second, 12 second, 14 second, 15 second, 17 second, 18 second, here 19 second, 21 second, 22 second, 23 second, 24 second, 26. Now it goes to 0. Okay, so it's like a Mumbai router is updating about 2.0 network and 23.0.0 network to Delhi router every 30 second. Okay, and let's do the similar configuration on Chennai. Here I don't have any RIP routes because I have not started the RIP routing protocol yet on Chennai router. So let's repeat the similar configuration here. Router, RIP, network. So only these two networks are connected, only that we will advertise. The behavior of dynamic is different than the static. In static, we enter the routes which are unknown to us or unknown to that router, right? And in case of dynamic, we do the exactly opposite thing. We enter the network which is known to us, because only that network you are going to enable, and the interfaces on that network will start advertising routes to the adjacent or the neighboring routers. Okay, after doing this, I believe we should have all the routes available, means all 5 routes should be available now. So you can see here 2 connected routes are there and 3 RIP routes are there. Okay, and if you analyze now this value is 2 and this value is 1. What's the difference? Why here we have 2 and why we are having 1 here?
The preferred value, the preferred network would be 192.168.2.0 with one value, I
Hmm.
believe.
Okay.
It's a
Uh,
hop count.
Oh, count. Yeah.
yeah, it's a hop count actually. And in case of RIP routing protocol, the hop count is the metric. So this value is a metric value. And here I have a hop count of 1 and here I have a hop count of 2. So from Chennai's perspective, if you see 192.168 1.0 is 2 hop away. This network is 2 hop away. First we have to reach to Mumbai and then second hop will be Delhi and then we can reach to the network of 192.168 1.0. Whereas for 2.0 network, we can reach to 2.0 network from Chennai's perspective. I'm talking only one hop is in between. That's a Mumbai router. Okay, that's how we can interpret it. And what is the role of this 120?
It's the administrative distance value, I believe.
Administrative distance. So if I have a static route, if I have a static route, these routes will not be visible. Let me let me demonstrate this on Mumbai router. So what I'll do, I'll put two static routes here, which is not required, just to show you how it will behave if I have a static routes and if I have a dynamic routes in combinations. Which one will lead? Okay, so let me add this network 1.0, the subnet mask after that. Okay, and the next top address is 12.0.0.1. Okay, not this one. We need to check the routing table. So see, for 3.0 I don't have a static route, so it is received via RIP routing protocol. But for 1.0 network I have a static route and I have a RIP update also. But RIP update we are not going to take. Static route we are going to install in routing table. Guys, you understood this behavioral difference for static route and RIP routing? What's the reason static routes got installed in routing table whereas RIP routing or RIP updates are still there but it's not getting used in routing table? What's the reason for this? AD. AD for or administrative distance. Uh, correct, Srijesh. This administrative distance is doing all this thing. You can see here the AD value is 1 here and RIP routing has a AD value of 120. So 192.168 1.0 if we are receiving via RIP but the AD value is 120, we are not going to put that entry in routing table. Better we will use a static route for that. Clear with this? Okay, I believe this point is clear for all of you. Now I'm going to do one more thing or one more variation in this. Okay, so what I'll do, I'll put two more network here and I'm going to add them to the Delhi router like this on fast Ethernet 0/0, and similarly at the Chennai end we have one more department like this. Okay, and I'm going to put the network like this 172.16.1.0 with the subnetted subnet mask 172.16.1.0/24. Here I'm going to put 172.16.2.0. Okay, let me put these IP address in the Delhi router and Chennai router. IP address 172.16.1.1, no shutdown. Same thing I'll do with the Chennai router. So both the networks are up now. Now what I'm going to do, I'm going to introduce these networks into the uh, routing protocol in the drip routing protocol. Let's see the effect. Router rip network 172.16.1.0, and similarly I'll add a network on Chennai as well. Router rip network 172.16.2.0. Okay, and I'm going to observe the effect of these two additional settings or configuration on the Mumbai router, because Mumbai is going to receive these updates from Delhi and Chennai. So let's cross check that at the Mumbai end. As you can see, we received the routes, but it's a 172.16.0.0/16, and what bad effect it will put in our routing that we are going to observe now. So I'm putting a command 172.16.1.1, means I'm doing a ping to this interface of Delhi. Okay, and see what is happening here now. If I repeat this again, guys, I want your analysis on this. What's happening here? This is my routing table and this is my output. Anyone can analyze and can give the analysis or observation on this.
Two packets are getting dropped.
And two packets, rest of the packets means like a alternate packets are
Yes.
reaching to the destination, and one packet reaches correctly, one packet get dropped,
Yep.
right? So what do you think, why, what is the problem with this? Obviously the solution means like a reason in this routing updates only, or this routing entries only, right?
I believe, I'm not sure, but I believe there is no destination host available
Mm-hmm.
on 172.16.1.0 network. We only have switch over there.
Or we don't have a clarity on this actually. We have a route, but it's not a clear route.
Yeah, means
It's
switch
like
is
a
not able to forward to any host.
right, right. Uh, you are correct up to some extent. We will analyze it in a further detail. Anyone beside Hussein, anyone wants to give a input on this?
Samir, actually, RIP is not supporting subnetted network.
Okay, we means like this slash 24 we are trying to advertise, but we are
Yeah,
failing to do it, and we are receiving a class full subnets here, means like
yeah.
one side
Actually,
to.
our existing network is /24, but
Mm-hmm.
it is taking the exact that network
Class full boundary,
subnet mask. Yeah,
class full boundary. Right, and one packet is reaching correctly, but one packet is not getting reached correctly. Means how the one packet is reaching correctly and the other packet, means your answer is correct actually, but we need to link this output with this interpretation of routing table.
We
So
can do trace 30.
no, trace it. Actually, we have to find out the solution from this only. What is the happening here? Let me show you. If I run the command show IP protocol, you will see there is one clause here. Maximum path 4 and automatic summarization is in effect. Okay, so summarization is happening here. 172.16.1.0, it is as Shrijesh has told us, it's getting advertised in the form of 172.16.0.0/16, and Chennai is also advertising the same update. 172.16.0.0/16. So what's happening at the Mumbai end, we are receiving the same update from two routers. One is Chennai, the other is that Delhi router, right? So it's like a load balancing is happening between two routes, because if you observe here, the metric is same for both the updates. Here also I have a hop count of 1, and here also I have a hop count of 1. So if I send the, if if we have a packet targeted for 172.16.1.1, one packet will be going to Delhi router and the other packet is going to be delivered to Chennai router. So the one which is going to Delhi router is reaching correctly, but the very next packet will get dropped at the Chennai location, as we don't have 172.16.1.1 here.
But how come from /24/16? That's what I didn't got.
This is a automatic summarization happening here, as I shown you on the output of show IP protocol, and as Srijesh is also discussed, that's correct actually. Show IP protocol, what is saying, automatic network summarization is in effect, even though you are means command we entered 172.16.1.0
Hmm.
slash 20 means like a 1.0 only. But if you see here on this running config, see what output we have under router rep. See, even though you put the command 172.16.1.0, but ultimately RIP is going to accept it as a 172.16.0.0, and it's going to advertise it in the form of /16 only, because it's a classful routing protocol, it's not a classless routing protocol.
So 8 + 8 subnet is taking total 16 unit.
So even if you take any other classless subnetting VLSM, it's not going to support it. So what solution we can apply on this? Any solution, how we can work out this problem?
I
We have
think
to replace this protocol with any classful routing protocol. So immediate replacement is what?
version 2.
Version 2. So simple configuration or minimum configuration we can do, it's like a version 2. So let's go ahead and do this configuration and see the output. So we'll go to router rep, and nothing big, just we have to change this version to 2, and I'm going to do it on all three routers. So I did it on Delhi. Now let's do it on Mumbai. Version 2, and at last we'll do it on Chennai. Version 2. Okay, and now if you observe, is there any change? Let's analyze. So still we don't have change. Reason, if you go ahead here in Delhi and again cross check what is the routing protocol output, show IP protocol, still network summarization is in effect. Even though you change the version, by default it's going to send the summarized, auto summarized uh, output. Okay, so manually we have to disable that. So manual disable is like this: no auto summary. So this command I ran. So I disable the summarization, and here also I want to disable the summarization. I can do that on Mumbai, but it's not required because we are not advertising any route on Mumbai which is like a summarized one. Okay, so I can skip this command on Mumbai, but result I'll expect now is the correct result. See, show IP route. Now I start receiving routes, which are the individual route with the correct subnet mask of /24, and the next stop is also correct. Okay, so I believe we should have solved, means the ping command should respond correctly. So that previous ping command, now I can reach to the destination correctly and no packets are getting lost because we don't have load balancing now. Is this point clear for all of you?
Samir,
Yes.
In RIP,
Mm-hmm.
uh, we are only providing our network name, right?
Network name.
Network like 192.168.1.0.
Okay, that network ID means, or network number. Okay.
Not providing subnet mask.
We don't provide subnet mask, but see, what happens, from initial discussion I'm saying, when we give a command like this, see, we are on Delhi, suppose, okay, when we give command like network 172.16.0.0, if you, even if you give this command, we are not advertising 172.16.0.0. What we are doing, we are enabling a routing process, RIP routing process on the interface which are coming under this 172.16.0.0 with slash
Hmm.
16. So see, this 172.16.1.1 IP address with the subnet mask of 24 is also covered under 172.16.0.0. Are you able to follow this? If what is the IP address on F0/1?
192,
No,
sorry, 172.16.1.0.
1.1. What is the subnet mask slash 24? Correct? Are you with me on this? Right? Hello. She you lost connection?
No, no,
No.
no. I can hear you.
Okay, okay. So are you following this now? Means we are not advertising this 172.16.0.0 by entering this command. Actually, we are enabling the RIP process for a interface whichever is falling under this network. So
Hmm.
172.16.0.0 can cover 172.16.1.1 IP address for this F0/1. Okay, and
Hmm.
once it is covered, whatever network we have on this interface, that will start get advertising through the RIP process.
Hmm. So we are providing 172.16.1.0 network, right?
But that will not take effect. See, I'll show you. Dot zero, and if you put question mark, do we have any option as a subnet mask?
No.
No, we don't have any option as a subnet mask or wildcard bits. So even though if you put this command at the end in show running config, what you will see? See, it is going to enter it as a class full only. But even if it is a class full, it is going to cover up this interface F0/1, and its network interface subnet mask will be taken. Okay, it is /24, then that network will get advertised.
Hmm.
Is it clear for you?
Hmm. Yes.
Okay. So now I'll again put this setup in the simulation mode, and I want to check on version 2 how the updates are behaving. It's like a what are the changes on version 2. So guys, are you able to figure out what changes are happening on the layer 3? Because layer 4 it is same, layer 2 all also not much changes are there, but what's the change on the layer 3?
Samir, can you show me how did you navigate here once again?
One second. I'm closing this, and previously I was here on real time, right?
Okay.
By default it is on real time, and just at the background we have this one more button. Okay,
Mm.
and just clicking here, that's it, and we will be in the simulation mode. Clear?
And we have to select the router.
Then these different protocols are there, right? So by default, like all protocols are shown. Okay, if I click on this button, and if I click this on this button again, it will select none of them. Then I'll go to edit filter and I'll select the RIP. Okay, because I'm interested in analyzing RIP only.
Mm.
Okay, so once we did that, it will be listed in the event filter. Okay, and then I'll click on capture and filter. What happened, this network will go into the it's like a statue position. It will be all stand still, and when we click on capture and filter, it start exposing the packet. Okay, still it will not go ahead unless and until I click on the capture and forward. So it's in your control how the packets are moving. Then I'll click on the individual packets and I can see the details of these packets like this. Okay, and I can see the updates on this RIP version 2 is going for 12 network, it's going for 23 network, it's going for 170 to 16 network. Okay,
Is it
and
like after we have finished all the configuration, then we can do this task
yes,
in
yes.
order to check if everything is completely
In,
fine?
this, what is the objective or purpose of doing this? I just want to analyze this protocol in a detail, so I can do that with this. Okay, and I can check like on IP level what are the detail, on UDP level what are the detail, on the layer 7 what are the details. All these details will get exposed, like port number, what port number we are using, what destination IP number we are using here. So you can see here this is 224.0.0.9. I want to bring you guys attention here, and we are having a multicast MAC address in the destination, and that is also related to this 224.0.0.9. Here I have a last number as a 9. Here also I have a last number as a 9. Okay, and starting number is 01, which is common for all multicast MAC addresses. Okay,
Hmm.
so this is how we can interpret it, and this information, it's there plainly written in the book, but if you do it like this, you will remember it more, I believe. Okay, let's bring it again in a real time mode, and this is what I want to share on the RIP protocol. Now we have few theoretical points along with this that also we will try to discuss. There is one important point in RIP discussion that's called as routing loop, and how we can avoid that routing loop in our network. Okay, so let me connect this pane. Just give me 2 minutes, I'll connect my digital pane here, and I'll explain you the routing loops, what is the routing loop, and how we can avoid this on the dynamic routing protocols. Yes, Rijesh, that's one of the important point. RIP version 1 is the broadcast based, whereas RIP version 2 is the multicast based, and we have analyzed the destination IP address also. Now I'm taking 3 routers here in the discussion. Okay, and I'm connecting them like this. Similar setup as we have seen in our topology. So I have a network like this. So this symbol represent our LAN network. Okay, so this first network is 192.168.1.0. The second one is 2.0, and the third one is 3.0. And similarly here we have 12 12.0.0.0 with /8 subnet mask, and 23.0.0.0 network, like this. Okay, so the routing table here on, this is my first router, this is my second router, and this is my third router. Let me check another color here. So in my routing table I have entries like this. This is 23.0 and 3.0. Okay, and rip routing suppose going on, and at 9 o'clock at particular time I given this update. At 9 o'clock I given this update. Okay, 9 o'clock 0 minute and 0 second. Okay, so what will be the next schedule update in that case? What is the update timer in our rip routing protocol?
30 seconds.
30 second. So we should have a next update schedule at 9 o'clock and 30 second. Okay, below. Okay, and suppose due to some problem, this link goes down. Okay, like this link goes down at 9 o'clock 5 second. Okay, but as we see here, the next update is on 9 o'clock 30 second. So this update we have already given at 9 o'clock. Okay, and my adjacent router know about these routes, like this. 2.0 is the connected one, 23.0 is also a connected one, and 12.0 is a connected one. Okay, and this network of 3.0 is one hop away. Okay, and the update this second router has given at suppose 8 o'clock 59 minute and 45 second. Okay, so what will be the next schedule update time? 9 o'clock 15 second. 9 o'clock 15 second. Clear? Guys, are you following this? Because I'm explaining this point with the time synchronization.
Yes, clear.
Okay, so this update will be given to adjacent router, and at 9 o'clock 5 second we lost this entry, so it will be removed from here. But as we receive this 3.0, this 3.0 from the second router, so we believe that 3.0 has lost connectivity to router 3, means router 3 will believe that we have lost the connectivity with this network 3.0 network, but probably this particular 3.0 network is hypothetically or virtually connected somewhere with router X. Okay, like this, because router 2 has update to 3.0 and it is one hop away. Okay, and maybe it is connected to a switch of 3.0 network. It's lost the connectivity here, but maybe it is connected like this. Okay, it's like a, because we don't have full idea in in a distance vector routing protocol, we don't have full map of the network. Okay, so we just have a routing by rumor. Okay, so we lost the connectivity, and we believe, means router 3 believe that we are receiving 3.0 network from some hypothetically connected routes, and that is one hop away, and that entry will get installed, routing entry will get installed as like this. 3.0 is again reachable via uh, 2 hop. This is reachable via 2 hop. Why I'm saying 2 hop? Because first we have to reach to router 2, then router 2 will be connected with some other router, and then it will be connected to 3.0. This is not the true condition, but this is how it will be interpreted at router 3. Okay, and at the next update, means 9 o'clock 30 second, this wrong update, this whole wrong update will be delivered back to whom? Router 2. Okay, this will be delivered to router 2, and router 2 is going to change this entry and put the wrong entry again, that 3.0 is now 2 hop away, not 2 hop, 3 hop away, because this 2 hop entry is already installed in the router 3, and that wrong entry will be given to router 2. Router 2 believe that first I have to go to router 3, and then router 3 is 2 hop away from 3.0 network. But 3.0 network neither connected to router 2 nor it is connected to router 2. Both routers are not reachable to 3.0. Meanwhile, consider a scenario where PC with source IP address 1.10 and destination IP address is like a 3.10, means source IP address 192.168.1.10 and the destination IP address 192.168.3.10. Okay, so this packet will go here, and that packet will go to router 2, then it will go to router 3. Router 3 is also not connected with that, so router 3 will give it back to router 2, router 2 will give it back to router 3, and it keeps on hopping between router 3 and router 2, router 3 and router 2. And this kind of situation is called as what? It's called as routing loop. Are you clear with this?
Samir, means when the connection has lost that time, right?
Mhm.
Okay.
So no, we lost the connection and we have not updated that thing immediately to the other
Okay.
router, and we received a wrong entry from adjacent routers. We installed that wrong entry into our routing table, and whole story started from that point onward.
Okay.
Okay, so if we would have updated other routers, means router 3 has updated other routers, that I lost the connectivity with the router 3, this problem would not have been arised. Are you guys clear with this concept?
Yes.
Okay, so that is called as triggered update. That's called as triggered update. Okay, so if suppose 9 o'clock 5 second this problem has arisen, so at 9 o'clock 5 second or within a second, or like 9 o'clock 6 second, we have given this update to the adjacent router. Adjacent router would not given us the wrong entry back to router 3. Okay, so it is called as triggered update. So triggered update is a loop prevention mechanism, but I can say that I'm reachable to this network one dot one hop away or 2 hop away or 3 hop away. But how I can say that this network is not reachable to me? Means I can tell you guys that this network is not reachable in a English language. But how this router will update that information to the rest of the router? Guys, anyone knows the answer? How we can give a triggered update in the form that I don't have reachability to this particular network 3.0.
Yes, I believe there would be a route poisoning and reverse
Correct,
route poisoning.
correct. That that concept is called poisoning. Root poison. In root poison, what happened? You give a update to the adjacent router with the infinite matrix. So guys, what is the infinite matrix for RIP routing protocol? Means a matrix which is not in reachability. So uh, see, the limit for RIP routing is 1 to 15, and 16, not 60. 16 is considered as unreachable network or infinite matrix. So one hop or two hop or three hop, that's okay. But if it is 16 hop away, we will not use that routes. Okay, so router 3 will give an update to adjacent router, that's a route poison, that 3.0 network is reachable to me on 16 hop. I mean to say, it will not be reachable to me and it's not reachable to you as well. So we are giving a route poison. This is a another methods, means like these two mechanisms we use to avoid this routing loop. Okay, and we have one more mechanism that's called as split horizon are interface based on interface basis. Okay, so these are enabled, this feature is enabled on the interfaces. So when router 3 has given updates to 3.0 initial condition, router 2 will not give the same update back to router 3. Okay, it's like a, suppose I'm meeting you first time and I'm giving my introduction. My name is Samir, I'm from this locality and this location, and I've done means I'm in this profile, and this is my background, all these details I give. So when discussion is going on, you are not supposed to give the same information back to me. Okay, because I know that information already, this is my information. So why this 3.0 networks information is going on the same interface back? We should not expect that information from the same interface. I mean to say, this 3.0 information should not return back on the same interface. If it is coming from some another router with another interface, that's a different story. But this 3.0 information should not come back on the same interface. Okay, so this is called as split horizon. Let me write it here. Split horizon. So these are
Samir, I believe in the route poisoning, there is
mm,
a 4 minute timer is also available, like the first page for the 30 second for the update timer,
mhm,
180 second for the whole timer, and
mhm.
after 180 second is the invalid, and after 240 second that is the flush
Ah,
timer. In overall 4 minutes, that will be drop the
correct,
router
correct,
3.
correct. So whenever we have a like a any network unreachable and updates are stopped, okay, so this timer is activated and it is 180 second, means like a invalid timers, we call it as a invalid routes timer, and 240 second is a flush down timers. I forgot to tell you about this in this. So when we initially we were receiving updates, show IP drop. For individual the summarized route, so 172.16.1.0 and summarized route was 172.16.0.0 with /16 subnet mask. So when we disable the auto summarization, Delhi and Chennai router start advertising 172.16.1.0 network and 172.16.2.0 network with the /24 subnet mask, and that time onward they stop sending updates on summarized route of 172.16.0.0. So that entry will start fading out from our routing table, but immediately it will not be replaced. There is a grace time for that, and that grace time is 180 seconds. So up to 180 seconds we will keep that entry, even though we are not receiving update for 172.16.0.0/16 network. Okay, so we will keep it for 180 second, and after 180 second we will not use that entry, we will keep it on the flush. So flush entry is a flush timer is 240 second, and after 240 second we will flush down that entry, we will not keep that entry any longer. Okay, so these timers are there in the show IP protocol output. You can see here this 180 second is invalid timer. Okay, and hold down timer we can say, and flush timer is 240 second. Okay, any other doubts guys? I believe we have covered most of the things from the rib. Actually this protocol is not stressed more on CCNA now. Okay, only few things we have to discuss, but why I'm discussing this, even though it is not more used more in enterprise business, but if you understand this concept on a basic level, we can understand the advanced concept of EIGRP OSPF, because we can come to the comparison between EIGRP OSPF and RIP. Okay, so we have done with this all discussion for today's. Rest of the things what we have in our discussion, let me check if anything is missing. Okay, rest of the comparison we will do in the next session of tomorrow we don't have session. Okay, so we'll do